A quick question. Does the electrical field get affected by the medium? Is it dependent on the medium? The answer is yes. We saw this indirectly in the last video. We told that the force between two charges, they are dependent on medium. Now, to handle this mathematically, we have a new term called as permittivity. Right? Permittivity talks about how sticky things are for an electrical field. Let's put it in this way. Let's understand it this way. See, we have a ball. We're trying to move that through air and say water. Does it fall at the same rate? Does it accelerate at the same rate in this two medium? Answer is no, is it not? Right? It's much difficult to move things in water than in air. Similar to that, the electrical field will vary depending on the medium. So the official definition of permittivity is nothing but it's a property of the medium which determines the electrical force between two charges that is situated within the medium. A small diagram showing that we have two charges, but in two different medium, we can see that the forces are not the same. Right? Now the question is, let me not show the next slide. Where does this force disappear to? See, it's either increasing or decreasing. Is it not? The force will increase or decrease. Of course, in vacuum, it is x, and in medium, it is say x by 3 and so on and so forth. It reduces. So where does this disappear? Where does the force disappear? Right? It disappears or it is stored in terms of potential energy. So the question is, so where does the pull or the push between charges disappear? It is stored in terms of potential energy. So your second perspective on permittivity, that is official definition and all, we need to dive in detail so that we understand the concept better. If we understand this, we can understand the concept of capacitor better. Capacitor is a very important device in your electrical circuits. It smoothens out the signal, so on and so forth. So all your radio and all your devices, they use capacitor. To understand capacitor, we need to understand permittivity very well in detail. So I'm doing this. So please concentrate. So now, second perspective on permittivity. Permittivity is a measure of material's ability to store electrical potential energy under the influence of electrical field. So a device which has more permittivity has more electrical potential energy stored. Okay, more and more. More and more. Right? All of this helps. So it is useful, okay? Now the question is, let me not go to the next slide. Now the question is, yeah, this is potential energy. And the idea of potential energy is that energy which is stored in form of different configuration or different heights and so on and so forth. That's your potential energy. So in case of this medium, how does this potential energy appear as? Right? It's a medium. Medium per se does not have distance and all of that. Right? We're not talking about shifting a medium and so on and so forth. I might be sounding a bit confusing. The question is, how is the potential energy? What kind of potential energy are we looking at? Is it configuration or is it height? Yes, it is configuration. So how can a medium change its configuration? Well, by changing its polarity. You can see that everything is interdependent. That is, we have studied the polarity aspect where very first video. So we have a charge, the balloon experiment, remember? We have a charge, we have the same charge in presence of, say, this is negative, right? We have a medium, we have a rod which is negatively charged. So what happens? The electrons will spend more time on the left than on the right. So the atom got polarized. So what did we study? We studied that forces or the field, electrical field, they are dependent on the medium. Now, where does this energy disappear? Where does this force in form disappear? Well, it's stored in form of potential energy. What kind of potential energy? By changing the configuration. What configuration changes in a medium? The polarities. Things get polarized, right? This is not polarized and this is polarized. That is, we have the positive and negative in a separate set of space. The third perspective on permittivity is basically it measures how easily a material can get polarized. If a material can get polarized faster or easily, not more than faster, it's easier, then more potential energy is stored in that. And so the force between the charges will reduce. Again, this factor is going to be very useful for your idea of capacitor. Okay, guys. So to conclude, if a material is consuming a lot of energy in polarization, it is going to store a lot of potential energy, and thus it's going to make the electrical field. Okay, I am not reading it right. Let me read it right. If the material is consuming a lot of energy in polarization, it will store more potential energy and thus making it difficult for electrical field to pass through it. Thus, it's more sticky. Okay, the word sticky, it came back again. Right, guys? So let me just recall. Permittivity, one of the easiest way to understand it is in terms of stickiness. More the stickier, more the permittivity. Okay. So official definition is that it is a way of talking about how the medium will affect the electrical forces. So not all the medium will have the same effect. So where is this force or where is this energy disappearing? Well, it's stored in terms of potential energy. What kind of potential energy? By changing the configuration. What configuration changing? By changing the polarity. Things will get more polarized. And this aspect of things will help us understand the concept of capacitor better. Okay, guys. So write all of this. It helps. It's going to help.